Hi, I'm Aries Itten. I'm an instructor here at SAS. I teach classes on text analytics, optimization, and machine learning. And today we're going to go over an example in SAS Visual Text Analytics of using scientific literature to look for associations between certain drugs and diseases or negative outcomes. So you can follow along with this demonstration via the virtual lab. So I've just opened up my virtual lab. And before I kind of introduce our example, I'm going to open up SAS Visual Analytics to look through a couple of sort of diagrams that illustrate what we're going to be working on today. So I'm going to open up Google Chrome on the virtual machine. And on the virtual machine in Google Chrome, there are some bookmarks. And we're going to go to SAS Drive on the top left here. And we're going to sign in using our user ID student and password metadata 0. This is listed in the documentation, and it should be auto-saved here in the software anyways. I don't need to be an administrator, so I'm going to click No for opting into assumable groups. If you're interested in exploring what the software looks like as an administrator, feel free to click Yes, but we won't use that functionality here. Before I dive into visual text analytics and show you the example, I'd like to set some context by showing some of the results that we'll be getting in visual analytics. So I'm going to click on this Applications menu on the top left. And I'm going to navigate over to Explore and Visualize, which will take us into our SAS Visual Analytics interface. This is an interface designed for kind of building custom dashboards and plots, and we're going to use it to summarize some of the results from our text analysis. We're going to look at the results first and then go back and see how we created some of it. So you should see a project here in Visual Analytics called PubMed Analysis Dashboard. So I'm going to open this up. Just click on it to open it up. And the first thing I'll mention is that we've downloaded a bunch of scientific literature abstracts from the PubMed website. So we went to their website and pulled this data into a SAS data set, and I've done some analysis on it here in the output. So what we're looking at is a collection of topics derived from the text, along with key terms in the abstracts that we were looking at. And you can see immediately when I went to PubMed to search for abstracts, I specifically searched for topics around the drug ranitidine. The drug ranitidine is used for gastrointestinal problems, but it's been recalled as a result of the formation of cancer-causing chemicals in the drug. So what we're going to look at is look through the literature to see if we can identify that association in the scientific literature abstracts, with the idea that perhaps if we'd done this analysis before the drug was recalled, we could have gotten extra information about the drug safety. So I'm kind of imagining we're public health experts or we're doing research on public health to try and better understand the safety of certain drugs that we might have some suspicion about. Of course, if you're working in the pharmaceutical industry or in some regulatory capacity, you might have other topics that you're interested in looking at. You might want to perform different searches. I chose this one because it's pretty easy to understand and connected to a well-known historical event. So here in the data, just looking at this automated text topics tab, what we see are a bunch of topics derived automatically from the collection of documents that we gathered, which was those collection of abstracts from scientific literature related to ranitidine and the brand name of ranitidine, which is Zantac. So for example, the first topic we see has keywords gastric, secretion, acid, pH, which kind of makes sense given that we were searching for this drug ranitidine, which is really a stomach acid blocker in some ways. And if we click on this topic name here in Visual Analytics, it'll highlight key terms over here on the right related to this topic. So of course, the keywords gastric, secretion, acid, pH show up, as well as other topics like H2 receptor or omeprazole, which are both kind of words related to drugs that are useful for gastric secretion reduction, basically. And if we scroll down, we can see sort of a document score, topic relevance for each of our documents. So in this case, documents represent abstracts from our scientific literature. So all of this analysis was kind of done automatically by SAS Visual Analytics, and it allows us to explore the data a little bit more. And of course, we can choose different filters to look at kind of different topic areas. And it takes just a second to load here. And so now for this topic, we see the word histamine and receptor is much larger because those are more important terms for this topic. But as you'll see, a lot of these topics are fairly similar since we gathered a bunch of abstracts specifically related to drugs associated with stomach acid issues. This analysis might not take us everywhere we want to go, so let's move to the PubMed Text Analytics tab. On this tab, this is just kind of another page that I've created in Visual Analytics. We explore some of the results from the text analysis that we're going to perform. So our goal in text analysis is to kind of look for associations between drugs related to gastrointestinal health and cancer or negative outcomes that we might find. So you see here on the left is a list of kind of concepts that SAS Visual Text Analytics, that our text analytics software has found for us. The ones with the keyword NLP beforehand were created automatically by the software. So for example, there's a lot of noun groups, and if we click on NLP noun group here, we can see documents and text matches with NLP noun groups, which are basically groups of nouns. So those are things like H2 receptor, which might be a kind of noun that is a compound word. A couple of other examples. Here's some matched text for NLP noun group: myocardial ischemia, untreated cases, mean consumption. So these are kind of identities or entities that the software is extracting based on the idea that they represent a single noun. And usually it's kind of subject specific. So a lot of this is directly related to pharmaceutical research and adverse events. There's also some other topics, though, like carcinogen, that we created ourselves. And I guess I shouldn't call them topics, I should call them concepts. So there's another concept called carcinogen. And if I double click this, I can see some keywords associated with carcinogens. And you'll notice this really big one, NDMA. This was the carcinogen that was found to accumulate in ranitidine over time. And we'll talk about that in a little bit more detail as we work through the text analytics. So that's kind of a keyword. We're looking for the formation of NDMA, which is a known carcinogen, in these gastrointestinal health drugs. And of course, we can kind of back out of this filter to explore different kinds of concepts. And you'll notice if we kind of look in the documents, we find a lot of noun groups, a decent amount of measures, sort of like drug dosages or various measures. There's some dates, so for example, weeks or certain date elements that are more general than weeks. And then some of our custom concepts that we're going to talk about shortly, how we create them: drug interactions, carcinogens, negative effects. There aren't as many of those concepts matched in the documents. And then finally, this last tab is our full text, just in case you want to actually explore the abstracts. You'll notice that we have matched text, which is extracted as associated with our concepts. So various kind of keywords that we're extracting based on our analysis goals, along with the abstract of the text. And of course, you can see here that we're extracting multiple terms or multiple concepts from each abstract, from each text document. So just to kind of review, we're going to look over a bunch of abstracts from scientific literature to explore the association between these two drugs, ranitidine and Zantac, which are basically the same drug, just the generic and the proprietary form of it, to look for associations between these drugs and possible cancer-causing chemicals and disease. And of course, our investigation here is motivated by the knowledge that I believe in 2019 or in the beginning of 2020, the FDA issued a recall on Zantac and ranitidine because over time, when it's stored in kind of normal room temperature conditions or in someone's house or in like a drugstore or pharmacy, it accumulates NDMA. So at first, when you test these drugs, they're safe to use. But then after a period of months, they become less and less safe. And the FDA decided that there isn't a clear threshold, and they issued essentially a recall on these drugs and no longer offer them on the market. So we're kind of imagining that we might want to do this text analysis before we find this warning and this issue. And thus, we're kind of looking for the association in the text. And the idea that I would think is you could apply this to other kinds of drugs or diseases that you might look through, or more generally, other kinds of scientific or public literature to look for associations between topics of interest. So let's dive in to see how we actually create our text analytics examples and how we create these outputs. So let's go over to the Show Applications menu in the top left. So we're going to leave Visual Analytics and move into SAS Model Studio. So I click this button in the top left, and then I go over to Build Models. I click Build Models, and you'll see in the URL bar that it takes me over to SAS Model Studio. And we have a list of projects. Now I have this backup project. If you don't want to follow along with the work that I'm doing, feel free to just open the backup project and explore. I actually created this in order to show you that example in Visual Analytics. So Visual Analytics actually uses some of the output from this backup project. But let's go ahead and create a brand new project so that I can actually walk you through the steps of building your Visual Text Analytics rules. So I'll click New Project, and I'm going to name this PubMed Text Analysis. And I'm going to switch the type. This software is used for machine learning, for forecasting, and for text analytics. So I'm going to change the type of my project from data mining and machine learning to text analytics. And I'll leave this default template, which is just a collection of nodes in this pipeline. So it's going to basically be a collection of analysis elements for doing text analysis, and I'll modify them later on. We have to choose a data set. We're going to use those articles I downloaded from PubMed. I've already kind of aggregated them into a SAS data set for you, but the PubMed articles, the abstracts, are publicly available. It's easy to download. You're welcome to use them as you see fit, as long as you give PubMed credit. So I'm going to click Data, or I'm going to click Browse under Data. And my data is actually in memory already. So here under the Available tab, I could just click PubMed Article Pool and click OK. I had to load it into memory to show you that the Visual Analytics dashboard. However, it might not be in memory on the virtual machine that you're using if you're trying to follow along with this demonstration. So I wanted to show you the steps to just import this file. So on the virtual machine, we'll go over to Import. We'll select Local Files, Local File. And I'm going to search for this file. I just put it in the My Documents folder here on the virtual lab. So it's kind of saved already right here. And it's called pubmedarticlepool.sashdat. So it's just under the PC in My Documents. We'll double click on PubMed Article Pool. These are articles that we've pulled from the PubMed database. And we can just import it with the default settings. But I'm going to click Replace File because I already imported it earlier when I was preparing that backup demo for you. You might have to import it again here. So that's why I wanted to illustrate this importing. So I'm going to click Replace File and I'll import. Once it's imported, I'll click OK. And I'll save to create my project. So I've selected the PubMed article pool data from the public CAS library. So it's just stored in a public folder on the SAS server. And I'll click Save to create my project. Takes just a second to kind of create the metadata for the project. And the first thing we see when we create our project is the Data tab. The Data tab contains basically metadata about the columns in your original data set. So here's the data, PubMed article pool, and here's a list of columns. And it's identified a unique ID as basically a key variable for all of the different abstracts in our document collection here. But it gives us a warning that says you must assign a text variable in order to run a pipeline. In this case, we're trying to analyze the abstracts of these articles. So we're going to select abstract here. We can either click the word or click the checkbox. And we're going to go over on the right, and this is kind of how these graphical interfaces work. On the left are kind of global controls for the page. And then when you select elements in the page, like the abstract element here, the abstract variable, on the right are specific settings related to the element that you've selected. So under role, I'm going to switch it from none to text. You'll notice there's an option for the category role. We can set variables to category roles to create kind of category rules to try and determine which documents correspond to this category. So I kind of think that we might have a categorical variable, for example, maybe like a sentiment variable, how we feel about these documents or how these documents feel about basically the drugs or the health outcomes that they're analyzing. And we might want to try and categorize documents as, having healthy outcomes or unhealthy outcomes. We don't have that column in the text, so we won't do that here. We're just going to select abstract as text. So we're going to skip using categories and creating categories, but I wanted to emphasize that that is an option. And notice when I set the variable abstract to text, it automatically detects that the language is English. I just like to highlight there are a lot of languages here. So I'm always impressed by the variety of languages available in Visual Text Analytics. Of course, you want to be careful to choose the right language to make sure that you're using the language that your text is actually written in. And we've got some other columns in our data, the affiliation of the author, some information about the author and the title and where it was written and what journal it was published in. And if you want to kind of briefly explore the data, there's this View Table button. We can click on View Table. It takes just a second to load the table. And we can see we've got articles from a variety of different journals. We have the article title, the author name, and then the actual text that we're interested in analyzing is this abstract column. So we could look through, kind of read some of our data, but we'll go right into the analysis. So I'm going to click Pipelines. So now that I've set a text column, I'm going to start trying to find those concepts that I was looking at in visual analytics. So we'll click Pipelines. This is the default text analytics pipeline that is included. We're mostly going to be focusing on the concepts node. I talked about categories. The categories node allows you to kind of learn automatic category rules. In this workshop, we're focusing on concepts. The concepts node kind of extracts keywords and key collections of words that might be relevant to your analysis goal. Text parsing kind of looks through all of the text and creates a term by document matrix, basically identifies terms in the text and does a lot of analysis. Sentiment analysis is just a pre-built SAS sentiment analysis model, not very relevant for this particular project, given that we're analyzing scientific literature rather than things like customer reviews. And we didn't filter scientific literature only on health outcomes. So we might be looking at health outcomes. We might be looking at chemical research on the drugs. So I'm going to right click on the sentiment node and select delete to remove it from the pipeline. If you're interested in exploring the results of the sentiment node, feel free to leave it in for yourself. I just wanted to delete it to save a little bit of time in running the pipeline since we're not going to use it. Additionally, there's actually a trick that we're going to use to enhance our concepts node. So I'm going to right click on the concepts node, select add parent node, natural language processing, and I'm going to put another text parsing node before the concepts node. It seems a little bit redundant because we already have a text parsing node below the concepts node, but if we parse the text before we run the concepts, it enables us to explore some of the text in an interface within the concepts node that'll allow us to look for similarity between words. So it's going to be a powerful analysis tool to enhance our concept building techniques, which is what we're going to spend most of the rest of the workshop on. So that being said, I want to run the pipeline, but before I do that, let's just enable misspelling detection on my first text parsing node. So it'll say text parsing 1 because that was the one we just added. So I'll click enable misspelling detection, and I'll go ahead and run the whole pipeline. While the pipeline is running, I'll just briefly mention the text parsing node is based on a minimum number of documents. So you can see that if words do not show up in more than 3 documents, in 4 or more documents, they're just not included in the analysis. So the text parsing node is kind of choosing what words to keep and reject. And one of the ways I think about it is that the software doesn't really know what any of the words mean. It's just kind of looking for statistical associations between words. So words like the, be, and don't contain a lot of meaning in terms of the text because they're used so frequently. They're just present in so many different documents. So we use a stop list to eliminate words from the analysis that we think are too common or irrelevant, along with words that are too uncommon, because the software, again, doesn't really know what the words mean. So if the word is really uncommon, it means it doesn't have a lot of statistical associations for the word, so it doesn't know very much about it. The software does give us the option to use a stop list or a start list. By default, SAS provides you a default stop list, but if you're working in a very specific industry or field, you can create a start list of keywords that you want to use. And then the final thing is that we are enabling misspelling detection, so we're going to find misspelled versions of our words in the text parsing node here. Now that the text parsing node is finished, and even before the rest of the pipeline finishes, we can right-click on text parsing 1 and select results. Oh, actually select open to open it up. I may as well highlight this now. A lot of our nodes have results, which are kind of summary information about what the node has done, but our text mining nodes often have the ability to open them to explore what's going on inside the node. So let's click open here. And this allows us to explore kept terms, dropped terms, as well as matches in the documents for these terms. So we see on drop terms, as I mentioned, the, of, be, and. These are words that are so common that they're just not included in the analysis. So they're on the default stop list that SAS provides. So if we scroll down under dropped terms, we can see that some of the dropped terms are dropped here because they're only showing up in 1 document or in fewer than 4 documents. So all of these terms are kind of automatically dropped because they are not included in enough documents. If we look over at kept terms, we have important terms like ranitidine, patient, gastric, milligrams, ulcer. Notice if we open up ranitidine, if we press this little caret next to it, we clicked enable misspelling detection. So the software automatically identified misspelled versions of the word ranitidine. And so you can see here's the primary one, ranitidine, that shows up in 4,500 documents. But it looks like some of our documents, some of our scientific literature abstracts may have misspelled the word ranitidine. Rantide, rantidine, rantidine. And those are all grouped together in the software now under the word ranitidine. So they're kind of treated as instances of that. So we don't have to do separate analysis on all of these different misspelled versions. Another thing that we can do here in the text parsing node, so of course we could select these terms and look for matched documents to see, in which documents does ranitidine occur, and it's going to highlight the word ranitidine in those documents. But we can also, let's go to ulcer, for example. So if we click on ulcer and select ulcer, and let's unselect ranitidine now. With just ulcer selected, we have a couple of options over here. I wanted to highlight them. We can show similarity scores, which shows words that are similar to the word ulcer. And we can also show a term map to show terms connected to it. Let's click Show Similarity Scores because we're going to find this a useful functionality when building our concept rules. If I click Show Similarity Scores, here's a list of words that are similar or show up in similar context with the word ulcer. So the number one is duodenal, because duodenal ulcer is a common term in our documents about gastric health and drugs related to gastric health, along with the word gastric ulcer. And heal, a lot of our abstracts might have been related to healing ulcers or whether the drugs had an impact on healing ulcers. And then we have things like ulcer patient, peptic ulcer, proven, ulcer group, active ulcer. So a bunch of similar words identified by the text analytics software for us based on selecting this word ulcer. So all of this information from the text parsing node then gets passed on to the concepts node. And you can sort of see why I put this above the concepts node, because we're going to use some of this information and the grouping together of terms with the misspelling detection to help drive our concept rule building. So let's close the text parsing node here. Let's right click on concept. Actually, before we right click on concepts, let's left click on concepts. There aren't a lot of options. Let's just select include predefined concepts here because I wanted to show you some of the predefined concepts that SAS creates. So I'll click this. It does require me to rerun the pipeline. So once I've selected include predefined concepts, you'll notice the concept node, the checkbox turns into an empty circle because we need to run it again. So I'll click run pipeline. It takes just a second to run. Now that the concepts node is finished running, we'll right click on the concepts node and select open. This opens up the concept node, showing us the predefined concepts that SAS included. So we can see over here on the left, we get 9 predefined concepts, as well as giving us an interface for developing our own custom concepts. So let's look at the predefined concepts real quick. If I open up predefined concepts, I'll select NLP date, for example. Because these are SAS-defined concepts, we don't see the code. This code is LITI code, which stands for Language Interpretation Text Interpretation. And it's kind of a text extraction and summarization language that is built into SAS. So these rules are written in that LITI language, but they are proprietary rules that SAS kind of updates and develops to try and ensure that we provide useful concepts to our customers. So we don't see the rules, but we can look for matches here. So if I click on matched, we see matches for the rule NLP date, for example, from September 2019 to February 2020, in 1996 through 2008, virtually completely through 2018. So it highlights the dates, but it misses some of them. 1,000 is a valid date, but we weren't doing a lot of drug research in 1,000 years after the Common Era. So as a result, it is kind of a misclassification. But I kind of wanted to highlight that we get things like normal dates, July 28th, 2015, as well as date ranges, and even this week, which kind of represents information about a date. So this is a pretty general rule that SAS has created for identifying date elements. Similarly, and I kind of find this one's often relevant for drug research and scientific work. We have NLP measures, so things like 4 weeks or 1.2 grams or 300 milligrams. So we can capture a lot of different measurements that might be useful in specific applications. Of course, if you're working in an even narrower field, you might want to build your own measurement rules that are specifically applied to like the unit of measure that you care about. So you might be looking for lengths or weights or volumes, for example. Let's go ahead and start defining our own concepts using this language interpretation, text interpretation language, using this edit concept option. So let's scroll down on concepts over to custom concepts. Right-click on custom concepts and add a new concept. I'm going to name my concept underscore carcinogen underscore. Why do I put the underscores in front of my concept? Well, your concept names can actually be included in other concepts. So you can create like a nested hierarchy of concepts. And you can reference words or concepts in those concept rules. And it's good not to mix them up. So we kind of want to make a distinction between the word carcinogen and the concept carcinogen. So we put underscore in front of the concept when it's a single word. If it's 2 words, we usually just connect them with underscores. So that's kind of a standard that we have in order to avoid confusion in creating these hierarchies of concepts. So I'll create the carcinogen concept. And I'll start inputting some rules. And there's a lot of documentation for these rules. So I'll include the documentation in the notes that you can follow along for following along with this demonstration. But I wanted to emphasize that each of these rules is just kind of an example of a larger set of rules that we can use. So I'll start with concept NDMA. So it's going to match strings containing MDMA or with the words NDMA in them. I'm also going to include concept carcinogen at, and that at symbol is basically selecting, it's kind of a wildcard operator. It's selecting carcinogen, carcinogens, carcinogenic, anything carcinogen with any word carcinogen with any sort of strings afterwards as part of one word. So it's kind of a wildcard to select different versions of the word carcinogen. And we might also want to add some classifier rules identifying keywords in the text. Why don't we go ahead and see if we can motivate new rules based on some of the results from text parsing, in particular those similarity scores. Because we ran the text parsing node before our concepts node, we can look at this textual elements box in the bottom left. And I'm going to filter and just search carcinogen. And I'm going to click carcinogen here. And when I select it, currently the similarity scores are grayed out. But if I exit this, I actually have to rerun the node to get those similarity scores because I created this new concept rule. So let me click run node real quick. So it took a little bit less than a minute to run the node. Now that the node has been run, we see matches for our concept. That wasn't exactly our goal. We're going to look at this textual elements again. But I just kind of wanted to highlight that we do see some matches for NDMA and the word carcinogen. Let's go back and search carcinogen again. And I'll select the string carcinogen. And I'm going to click show similarity scores. And I just wanted to highlight if that's grayed out, you have to run the node again. So I'll click show similarity scores. And we can see words similar to the word carcinogen. But notice that because we've sort of filtered on the word carcinogen, it's only showing words similar to carcinogen with the word carcinogen in them. So we remove the filter. But we're still looking at similarities for the term carcinogen. And we see carcinogen, human carcinogen, N-nitrosodimethylamine. That's NDMA, that chemical that we're worried about accumulating in ranitidine and Zantac. So let's add a classifier rule. And we can actually create a rule from the textual elements. I'm just going to type this in, but I'll show you what clicking that button does after. So I just see the word N-nitrosodimethylamine. So I'm going to build a classifier rule that just looks for that string in the text. N-nitrosodimethylamine, which is a known carcinogen in humans. And if we wanted, we could unselect carcinogen, select this N-nitrosodimethylamine, and potentially add this to create a rule from textual elements. So we could create some kind of more complex rule. This is a concept rule, which is looking for kind of this word in context or a couple of different spelling versions of this word, assuming that folks have misspelled it. So I think this could be a pretty powerful rule. I've stuck with a simple classifier, so I'm not capturing any of those misspellings. But I wanted to illustrate that you can kind of look through these similarity scores to identify just simple words that you want to add to the rules, or you can let the software kind of automatically create rules for you based on all of the information it has about this word. So I'll click cancel here for now. Now that we've got our new concept, it says validation is out of date. We can click validate rules to make sure that we've written the correct syntax. I sometimes mistype things and don't write the correct syntax, so it's always nice to validate the rules. And then, of course, we see matches for our documents. We won't see any matches for N-nitrosodimethylamine until we rerun the node. But before we do that, let's go ahead and create a couple of new custom concepts, some of the ones that we saw in that visual analytics report that we were looking at. So let's right-click on Custom Concepts, select Add New Concept. We're going to look for drug interaction, so we'll name this drug interaction. And we're going to add some concept and classifier rules. So we'll start concept, and notice we put kind of the keyword and then a colon and then the text, drug interaction. And I was going to put an underscore because I named the concept drug underscore interaction in order to kind of preserve my naming conventions. But here I'm just looking for the text drug interaction. And then I'll also look, and I forgot the ampersand at the end because I might also look for drug interactions. Let's do another concept rule, or another concept. We'll do drug-drug interaction. So we're also looking for interactions between two drugs. Let's do classifier interaction. So any sort of presence of the word interaction. So we're going to highlight the word drug interaction or drug-drug interaction or interactions. We're also just going to look for the word interaction on its own, along with concept contaminant, because it's possible that drug interactions lead to contamination or that there are some contaminants when we have drug interactions. And of course, once we've written these rules, we can validate them. And once it says our code is valid, we in theory could run the node with no issues. Now, before we run, well, actually, let's go ahead and run the node now and look at the results. We'll rerun it once we add one more concept afterwards. So I'll click Run Node. Now that our node has been run, and it takes a little bit less than a minute to run here, we can see matched documents or matched text for our node. So here, for example, we see the trace organic contaminant treatment. There's a possible drug-drug interaction. They didn't put the hyphen, so we didn't capture it with the drug-drug interaction concept, but we captured it with the regular drug interaction concept. Here's some hyphens, so there's some examples of drug-drug interactions. So we can see this matched text highlighted here. Now, at first glance, this just sort of looks like searching through the text for words, but we can create more complex rules, and that's what we're going to do in our next example, is create kind of a nested sequence of concepts with more complex rules. But I also wanted to highlight, and we're going to see this at the end of this workshop as well, we can actually output these rules as scoring. And so then we can score new documents or score existing documents based on these rules and output it in a data set. And that's the data set that we actually use to create that visual analytics dashboard illustrating some of these key topic areas. So let's go ahead and create a new custom concept. I'll right-click on Custom Concept. I'll click Add New Concept. And I'll name this Negative Effect. And I'm going to look for some negative effects from drugs. But what I really want to highlight are just the negative effects from drugs, but there are a ton of different kinds of negative effects that we might run into. So I'm going to create another concept, kind of a supporting concept. So I'm going to right-click on Negative Effect, and I'm going to click Add New Concept to create a sub-concept that I'm going to kind of use to create the negative effect concept. So I'll click Add New Concept on negative effect, and I'll name it Negative Effect Helper. And in this negative effect helper, I'm going to just put a bunch of classifier rules for negative effects, along with a couple of concept rules to capture some variable ways that we can represent the strings. So we'll start with classifier negative effect, classifier detrimental, concept, because now we want to capture different versions of this word, contaminant, with an ampersand afterwards, with the at symbol afterward, or not an ampersand, with the at symbol afterwards, in order to emphasize that we want to catch a wildcard. Contaminants, that's probably the only other variation. We also want concept, contaminate, with another at symbol afterwards, because we might want contaminates or contaminated. Classifier, dangerous. Dangerous is a negative effect. We do not want our drugs to be dangerous. Classifier unsafe, so we're going to look for the string unsafe. Concept adverse reaction with the at symbol, so adverse reactions, adverse reaction. And finally, classifier contamination, because the contaminate and contaminant, the wildcards weren't able to capture the word contamination. So a bunch of different ways for us to identify negative effects. Of course, with subject matter expertise, we could potentially include more of these words, more different words that we might know in our abstracts are related to negative effects. Of course, in this particular case, we might use some subject matter expertise about gastrointestinal issues to write some new rules about negative effects that you might run into with gastrointestinal issues. I'll keep this one a little bit simple so that we don't spend too much time diving into drug research topics. So let's go back to the negative effect concept. Oh, before we do this, let's right-click on negative effect helper and select set concept behavior and move it to supporting. What does this do? It indicates that this concept is really just a subconcept of negative effect helper, and the output kind of doesn't get displayed fully when we output our concepts. So we're not interested in looking at match text for the negative effect helper concept. We're going to use it to calculate the negative effect concept, and we're interested in matching text for this one. So let's actually use this, and we're going to now build our first kind of more complex concept rule. So we'll start concept rule, colon, and then we'll provide our concept rule. So far, we've just kind of been matching text and variations on strings. The concept rule actually looks for text that matches specific conditions. So in this case, our condition is sentence. So we're looking at matches within a sentence. And we're going to put underscore C, and that basically stands for in the context of. So it's around negative effect helper. So what is actually happening here? We're looking for versions or instantiations of the negative effect helper concept. So anything that matches this negative effect helper concept, so any of these rules, in the same sentence, so that's underscore C, in the same sentence, this in the context of negative effect helper, in the same sentence as, and now we're going to look for our drug names that we're interested in. So we're doing a OR rule, and it's ranitidine. And because we use that text parsing node, it captures all the misspelled versions of ranitidine as well, which is very convenient. Or Zantac, which is just a brand name for the ranitidine drug. That, again, neither of these are on the market anymore because of an FDA guidance. So here's our concept rule, and this was a confusing one, so I'm just going to click validation to validate my rule. But I wanted to highlight what's actually happening in this rule. So now that it's been validated, we can actually look at it again. So the concept rule, what it's doing is it's looking for matches of negative effect helper in the same sentence as ranitidine or Zantac. There's other kinds of concept rules that we can use rather than just the sentence rule. There's also a distance rule, so we can look for strings within 5 words of a different string or a different word. And there's all kinds of other rules that we can use to build more complex concept rules. And of course, that distance, you can choose how big you want that distance to be. Now that we've built all of our rules, let's go ahead and close our node. Now that we've created our negative effect concept rule, along with our negative effect helper subconcept, let's go ahead and run this node to look for matches. So we'll click Run Node in the top right here. And it takes just about a minute for this concepts node to run with all of the new concepts that we've added. So we can click Matched Text here and look for matches for our negative effect concept. So we can see the word contaminated. So we identify, and you'll notice actually that this is directly relevant to the application that we're looking at. Ranitidine is contaminated with N-nitrosodimethylamine, a suspected human carcinogen. And in fact, when this was published, it may have been a suspected human carcinogen, and now it's a known human carcinogen. We see adverse reactions, detrimental effect, emerging organic contaminants. These are all negative effects of drugs. And of course, if we were looking through our documents and we noticed things that we were missing, we could of course modify by either adding more rules here or by adding more rules here in the negative effect helper to identify more words that are related to negative effects. Of course, we can use these concepts outside of this graphical interface. If we right-click on the concepts node, we can download score code. If I click download score code, it's going to download SAS code that runs in SAS Viya that will enable me to output a scored concept table. And we use this score code that's currently just sort of still downloading. We use this score code in SAS Studio to score that PubMed data that we've been using, and then output that scored data into our visual analytics report that I was showing you at the very beginning of this workshop. And so we can use those scored outputs in other interfaces and in other graphics to create dashboards to present to business leaders or regulators or in industry leaders in order to provide more information about potential negative health outcomes that we're finding in this drug literature. You'll notice it puts the concept score code in a zip file. So if I just open it up, I just mostly wanted to show you that it contains SAS code along with this ASTOR file, which is a portable deployment artifact. So it really gives you a lot of options for deploying this. In the example that I used with the visual analytics report, I just deployed it on this exact same data set. So I opened up this score code and I modified it. And so I could sort of look at this. I could open up this score code. Let me just double click it. Let's just open it up at Notepad real quick to look at the code. Oh, and it doesn't format it. So let me view this in WordWrap. So you'll notice this is computer generated code, but the main thing is we just have to specify the names of some of our input libraries. And in fact, it would be easier for me to just open this code in SAS Studio. So I'm going to go over to SAS Studio here. So I just created a new tab and I clicked on the bookmark bar for SAS Studio. Oh, actually I should just copy all of this code. So I'm just copying all of this code into SAS Studio. You don't have to follow along with this in the demo because the visual analytics program or the visual analytics report is already created. I just wanted to show you this is the code that is automatically generated for scoring. And so if you want to score, you just point this to your input table or your input library where your table lives, your input table, the names of variables that you want to copy, the path to this ASTOR file that we're using, which is the sort of concepts model ASTOR, and you can actually see it right here. So you have to kind of provide this to the server. So once you provide all this scoring input information, it just runs some code to calculate scores and output scored data, basically the same scored data that we used to sort of visualize the PubMed text analytics dashboard that we created. And we can look through that dashboard to explore relationships between these gastrointestinal drugs and carcinogens and negative effects, and check out, how many times our concepts are appearing and which concepts are most prevalent. So just quickly before we wrap up, I just wanted to point back at Model Studio. This was just sort of a quick workshop on visual text analytics, trying to illustrate how you can use it to explore sort of drug-disease association. I chose this kind of case study on Zantac and ranitidine because it's kind of easy to understand and folks might be familiar with it. But of course, you could apply this kind of work to tons of different topics, looking through scientific literature for keywords that are relevant to some application of interest. Additionally, I just wanted to point out things we didn't cover in the software in this workshop. The topics node automatically derives those topics. We kind of saw them in Visual Analytics in that very first dashboard we were looking at, where it automatically derived topics for us. The way that this works, if you're interested, it uses a singular value decomposition on the term by document matrix. It's often called latent semantic analysis or latent semantic indexing. And it basically outputs a bunch of numeric columns that represent information contained in your text. So you can use these topics as inputs to machine learning models if you're building models. Additionally, we have the categories node that I kind of mentioned, and it creates Boolean rules based on a category variable, or allows you to write your own Boolean rules and output them as scores to basically determine whether or not documents match a certain category. So an example, if we wanted to kind of continue on this workshop, and we don't have time here in this session, but if we wanted to continue on this workshop, we could maybe create category rules to identify abstracts or in this case, literature documents really, that are directly related to negative effects from Zantac or ranitidine. So we gathered a bunch of documents related to Zantac or ranitidine, but not all of them were related to negative effects. So we could create a category rule, potentially based on some of the information that we learned from the concepts rules, in order to identify which documents are directly related to negative effects of Zantac and ranitidine. And some of them are, because there is an interest in sort of researching the potential cancer related to gastrointestinal drugs that people were noticing as a result of that accumulation of NDMA in those products. And of course, kind of the key takeaway here is that maybe having done this visual text analytics analysis before we knew about the issue between Zantac and ranitidine, maybe just sort of exploring drug disease association more generally, could have helped reveal to us a little bit earlier that this NDMA substance was forming in these drugs and was potentially dangerous for human health. So thank you so much for attending and participating in this session. And I encourage you in the virtual lab that you have access to kind of poke around and explore more features in visual text analytics. And of course, we do have a guide for walking through this workshop on your own. The guide does not include creating that visual analytics dashboard that I started with, but that dashboard is available on the virtual machine. So you can check that dashboard out at your leisure and kind of click through it in a more interactive way instead of just watching me click through it. Thank you so much and enjoy the rest of your SAS Explorer sessions.